For this problem, we're looking at the limit as x goes to 0 of the ratio sine of 3x divided by 5x. Now, if we were to go ahead and start by trying to plug in and solve, we would get sine of 0 over 0. Well, sine of 0 itself is 0, so we are looking at this 0 over 0 indeterminate form. So that's the sort of thing that we get on all of these problems that need a special trig limit. Now, this special limit is this one. And I'm going to use, instead of x, I'm going to use theta, because theta is really the argument of our trig function sine here. So this special limit that we're going to be utilizing here is that the limit, whoops, I just said I was not going to use x. I'm going to use theta. Limit as theta goes to 0 of sine of theta over theta. Notice that those have to match. That is going to be, that special limit is equal to 1. Okay, and we're going to utilize that in this problem, but we've got to algebraically manipulate this function so that we have the input of sine being the exact same thing as what's on the other side of the fraction bar. Now, this 3, even though it's super tempting to just pull out that 3 from your sine function, you can't. It's inside the sine function, and you can't just pull it out so that you have 3 times sine of x. That does not work. And so we've got to manipulate things separately here. So my suggestion here is, so that we could make this match our special limit, we're going to do kind of a change of variable. So if we let the 3x, that's our argument of sine, the thing that we cannot manipulate by pulling out, we're going to just call that theta. If we let 3x equal theta, then what we get is x is equal to theta divided by 3, just dividing both sides by 3. Also notice that as theta, as theta goes to 0, or actually as x goes to 0, because we're looking at the limit as x goes to 0. So as x goes to 0, notice that theta, which is equal to 3x, would go to 3 times 0, which is just 0. Okay, so what we really can do here is we can make a complete change of variables. So rather than looking at it as x goes to 0, it's looking as theta goes to 0, because theta and x are just a constant multiple of each other. Okay, so we're looking at the limit as theta goes to 0. We decided that 3x was just going to be our theta, so we're looking at sine of theta there. And then we've got on the bottom 5 times x. Well, we know now that x is going to be theta divided by 3, just by getting all of the x's replaced by thetas. That's what we have. And so what we get here then is something that looks like limit as theta goes to 0. We've got sine of x nice on the top, or sorry, sine of theta nice on the top. But see here on the bottom, we've got this constant multiple 5/3 times theta. Okay, so that constant multiple there that's on the bottom could simply be pulled out. So we could be looking at 1 over 5/3, because see that 5/3 lives in the bottom, so when we pull it outside the limit, it needs to still be in the bottom, times the limit as theta goes to 0 of sine of theta over theta. Now that limit that we have is exactly the special limit that we had seen up here. See, here's our special limit up here. It's exactly that. And so now when we're computing this limit, we just have that 1 over 5/3, which I'm going to go ahead and do that division by multiplying by the reciprocal. 1 times the reciprocal there, that would be 3/5. And then that's going to be multiplied by that special limit value of 1. So 3/5 times 1 is our answer, 3/5. So now, I did this really formally by going ahead and doing this change of variables, but really the most important thing is we need for the input of your trig function to match, or not just any trig function, the input of the sine function to match what's on the other side of the fraction bar. And so what I could have done is just pulled out this 5 here. So if I'm looking at the limit as x goes to 0, I can do nothing with the 3x. I cannot pull that 3 out. But see, what I could do is go ahead and pull out the 5 that's in the bottom. And let's see, I'll go ahead and pull it just out here to the side here, leaving me with just the x. Okay, so if I removed the 5, I have just an x there in the bottom. So at least I've removed the wrong coefficient, but I now need to insert the right one. So I can't move the 3 that's inside the sign, but I could put a 3 there in the bottom because it would just be a constant multiple there in the bottom. But whatever I do to the bottom, I'm going to have to do the top also. So that's where that 3 comes into the top. So now, as we're computing that limit, we could just pull out the constant 3/5 times the limit as x goes to 0 of sine of 3 times x over 3 times x. So now notice that the input of your sine function there matches what's on the other side of the fraction bar, and that's a key thing. The other key thing to notice is that as x is going to 0, both of those 3x's are going to 0 as well. And so really, if you can manipulate this using the constants appropriately here, you can go ahead and utilize your special limit to say, well, then that would just be the constant multiple 3/5 times the special limit value, which is 1, because I manipulated it in a way that the argument of the sign matches the other side of the fraction bar, and that argument also goes to 0. Once you've gotten those assessed, that special limit applies, and now we can get our final answer of 3/5 that way as well.